Okay, so we know that the okay, let's do this. What I would like to do is take what this says and break it down into its parts. So we know that the y value of every x-intercept, so here's our x-axis and here's our y-axis. And so if we put a graph there, what are we saying? We are saying that we know that the y value, so something, comma, something, the y value would be this one right here. And same thing over here, something, comma, something. We know that the y value of every x-intercept is always 0. So that is 0, that is 0, always. So the question is, how can we use that information to develop a formula that will always give us, and so this formula right here gives us, it produces the x values of the x-intercepts. So this formula, whatever this formula we develop, it gives us this. It gives us these values. That's what we want. We want to use the information that we know. We want to use the fact that that is 0 and that is 0. Those are always 0. We want to use that information to develop a formula that will always, we develop a formula, or we will develop a formula that always gives us this and that for every quadratic equation. So what I want to start by doing is writing out a quadratic equation in standard form with the placeholders a, b, and c, and we know that a represents a number in front of the x squared, and we know that b represents a number in front of the x, and we know that c also represents a number. And the first thing I said back here was, we know that the y value of every x-intercept is always 0. How can we use that information? Well, what we are going to do is we are going to put 0 in for y. Okay, so how are we going to use that information? We're going to put 0 in for y. And what is this formula that we are going to try and find? What is it supposed to do? It's supposed to give us the x values. And if it gives us the x values, then what we are doing is we are solving for x. Okay, we are solving for x. We are trying to figure out what x is going to equal. So that is going to be a lengthy process. We need to get x by itself. Solve for x means get x by itself. One of the most basic of algebra concepts. And so we've got all this stuff over here, all this stuff with x, and we just want x by itself. So let's start to get rid of some of that stuff. Let's subtract c. Subtract c. And we have negative c equals ax squared plus bx. Okay, so immediately we have a little bit less stuff right here. A little bit less stuff because we don't have that c out there anymore. A little bit less stuff. And what we want to try and do is continue to get x by itself. So I'm going to get rid of this a. And the way to get rid of it is to factor it out. So I have ax squared plus bx, and I'm going to divide by a so that they check out, which means I have to divide this by a also. And when I divide, if you remember, I put it outside of the parentheses. And that leaves me with x squared plus bx over a. Now, that second part is a little tricky, right? Because if I have ax squared plus bx and I divide both of those by a, I now have ax squared over a plus bx over a. And yeah, I know I wrote the same exact thing, but these can cancel. And I'm left with x squared plus bx over a. And remember, when I divide it out, it's technically on the outside of the parentheses. The way to double check that we've done that correctly is to take this and distribute. A times x squared would be ax squared plus, we've got bx all over a, and now we've got a over a, so those just cancel, so we got ax squared plus bx, which is what we originally started with. Lets us know that we did that correctly. Good thing about the video, you can rewind it so that that's not erased. So we now have right here something that has negative c on the left, and then a times this stuff. A times that stuff. A times x squared plus bx over a. So since a is being multiplied by everything in that parentheses, I divide by a. Check out, check out. I've got negative c over a equals x squared plus bx over a. And I am slowly getting rid of stuff around the x. You can see here I had an a with the x squared, now I don't. So let's continue. Sorry, negative c over a equals, what do we have? We had x squared plus bx over a. All right, so this whole thing here is not a perfect square. I can't take the square root of that whole thing and just end up with x. I can't take the square root because the whole thing isn't squared. If it was squared, I could just take the square root. But the whole thing isn't squared. So we are going to bring it over here and complete the square. We're going to complete the square. So we know that this part right here, x squared, goes here by itself. And then this part gets split in half and goes here and here. So what is 1/2 of bx over a? What is 1/2 of bx over a? Well, 1 times bx is bx, and 2 times a is 2a. Which means that I have bx over 2a here, bx over 2a there. Little tricky, but we can always do it backwards to show that it works. Bx over 2a plus bx over 2a. When we're adding fractions, we have a common denominator, stays the same. So we have right here 1bx plus 1bx. 1bx plus 1bx is 2bx. The 2's right there cancel. We're left with bx over a, which is what we started with. So we're looking good. We're at about 10 minutes, and so I'm going to go ahead and pause right there. Well, actually stop the video right there, and I will continue with part 2 in just a moment.